essential to our lives. We rely on them for comfort in our homes and vehicles, and businesses need heating and cooling for productive workplaces and industrial processes. Taken together, heating and cooling represent the biggest contribution to our energy consumption and the biggest source of greenhouse gas emissions, as can be seen, on the next slide, on the chart on the right. The space heating of buildings, which is provided primarily from burning of natural gas, and space cooling of buildings, which is provided primarily from compressing volatile greenhouse gases, represent the largest contribution to our heating and cooling needs, and on their own account for 17% of the UK CO2 emissions, as highlighted again in the chart on the right. However, these technologies are not efficient, neither friendly to the environment. A completely new approach on the way we heat and cool that is not based on the use of harmful gases is therefore required if we are to reach the 2050 zero carbon target. Moreover, given that 20 million homes and businesses in the UK are connected to the gas grid, ensuring this transition represents a major national challenge over the coming years. Caloric materials that displace large changes in temperature when subjected to changes in applied field can provide a solution for zero carbon heating and cooling that is both energy efficient and environmentally friendly. Next slide, please. Traditional heat pumps and air conditioners exploit phase transitions in fluids between a gas phase and a liquid phase in order to achieve heating and cooling. When sufficient pressure, which is labeled fill in this diagram, is applied to the gas, which is labeled phase 1, the gas transforms into a liquid, which is labeled phase 2, and energy is released, thus increasing temperature, as can be seen at the bottom of the schematics. When pressure is removed, the liquid transforms back to the gas phase and energy is absorbed, thus decreasing temperature, as shown in this case at the top of the schematic. Then, by repeating this cycle over and over, we can achieve heating and cooling. Caloric materials operate under the same principle, but instead of exploiting a phase transition between a harmful gas phase and a liquid phase, the material always remains solid and therefore does not pollute the atmosphere. Next slide, please. With this motivation, a roadmap consultation on materials under the aegis of the Henry Royce Institute was conducted with the participation of 8 academic institutions and 2 companies, all of which are listed here. After this consultation, key challenges and opportunities have been identified, which I will describe in the next slides. Overall, for this technology to succeed, research is needed across all technology readiness levels, both in academia and in industry. Next slide, please. The 4 strands of caloric materials, that is magnetocaloric materials driven using magnetic field, electrocaloric materials driven using electric field, elastocaloric materials driven using stress, and barocaloric materials driven using pressure, present different challenges, which are listed here. This is partly because of the different nature and partly because of the different level of maturity. Less prototypes exist for the bottom materials, but there is plenty of optimism for this, given that the thermal response is extremely large and for the first time comparable to the thermal response of the gases that are currently used in existing heat pumps and air conditioners. And moreover, there is plenty of room for discovery of materials with even better performance. For magnetocaloric materials, key challenges are reducing cracking under magnetic field in order to extend operating life, and reducing the magnitude of the driving magnetic field in order to reduce cost of permanent magnets. For electrocaloric materials, key challenges are improving fabrication of multilayers and increasing breakdown field in order to achieve larger thermal capacity. For elastocaloric materials, key challenges are reducing materials fatigue and increasing breakdown stress in order to extend operating life. And for barocalorics, key challenges are reducing hysteretic losses and reducing driving pressure in order to obtain materials that bring down the cost of compressors. Next slide, please. The opportunities are huge. The combined world market for space heating and cooling of buildings is large, and this market size doubles when incorporating other heating and cooling applications such as domestic refrigeration and commercial refrigeration, yielding a total of £300 billion with projected annual growth of between 5 and 10%. The achievement of heat pumps and air conditioners and related appliances such as fridges that operate using caloric materials instead of gases will permit decarbonizing heating and cooling, provide energy independence, and enable the UK to become the world leader on this emerging technology. Ultimately, this will permit reducing our greenhouse gas emissions while growing the economy and will secure our energy, environment, and jobs. Thank you very much.